So now it's time to talk about binomial distributions. We've already talked about what a probability experiment is, but now we're going to talk about what makes something a binomial experiment. An experiment is a binomial experiment if it meets these four different criteria. First, I'm going to tell you what the four different criteria are, and then I'm actually going to show you so it makes a little bit more sense. First of all, something is a binomial experiment if it is repeated a fixed number of times, if the trials are independent, if the trials have two mutually exclusive outcomes, either success or failure, and if the probability of success is the same for all trials, then if you meet all four of those conditions, you have a binomial probability experiment. So that doesn't make a whole lot of sense in itself, so let me show you an example. In a recent survey, it was found that 85% of households in the United States have high-speed internet. That might not actually be true. I just made that up. This is just an example. So if you take a sample of 18 households, what is the probability that exactly 15 of those will have high-speed internet? So first of all, we need to determine if this is a binomial probability experiment. Is the experiment being repeated a fixed number of times? Yes. Are the trials independent? Yes. Discovering that one home has high-speed internet will not affect the probability of other homes having high-speed internet. Are there two mutually exclusive outcomes? Yes. A home either has internet, which is a success, or doesn't have it, which is a failure. These events also cannot occur at the same time, like a house can't have it and also not have it, so that means these events are mutually exclusive. And is the probability of success the same for all trials? Yes, for every trial, the probability of success, in this case the probability of having high-speed internet, is 85%. So let me remove this, and I'm going to show you the formula for calculating the binomial probability. So in this case, this is kind of confusing. So we know that in this case, x is the number of successes. We are looking for the probability of 15 successes. N is the number of trials. We know that there are 18 trials because there are 18 households. P is the probability of success. We know that there is an 85% chance that there will be a success. So now that we know x and n and p, we can put those things into this formula. So it comes out to something like that. The probability of there being 15 households, 15 successes, 15 households with high-speed internet is equal to this thing, which is kind of confusing, so let's try to break that down a bit. That 18C15, that's actually a combination which you talked about a little bit earlier, so it turns into that thing. So now we have it split up into these three distinct parts, where I did some simplification, and now I'll do some additional simplification, and then some more. So we can find out that the probability of 15 is about 24%. Now, I just showed you a lot of stuff. Hopefully I'm not moving too fast. Remember, you can always pause this if there are different parts that you want to write down or that are unclear to you. But now let me move on and remove that. So now let's change the question up a little bit. Let's say, what is the probability that at least 15 houses will have high-speed internet? So I'm going to make that a little bit smaller so I have some room. Now realize that the probability of there being at least 15 houses means what is the probability of there being either 15 or 16 or 17 or 18. So that means we're going to have to find the probability of 15, 16, 17, and 18 and then add them together. And then that's the probability that there will be at least 15 houses with high-speed internet. And that's what I've done there. I did what I did before, but now we're doing that same formula 4 times. And if I break that down and break that down, we can find out that the probability of selecting a household, of selecting at least 15 households with high-speed internet is about 72%. And remember, you can pause to write that down if you have some trouble with that. I'm just taking that formula and simplifying it with each step. And that is a binomial probability experiment. As long as it meets those 4 criteria, you can use that formula to calculate the probability of an event.